Hello everyone, this is Sharmini Yasmin. Today I am presenting Lab 3, your first hack part 1 from Grand Canyon University course CYB Section Penetration Testing and Risk Management. In this assignment, I'll be describe on numeration and footprinting as part of the assignment Geoptrix Level 1 Virtual Machine. Um, mm, so, uh, Numeration and footprinting help us identifying the target machine, understand what services it's running, and start building a picture of its potential weakness. In the footprinting phase, the first thing that port 22 is open and port 22 is associated with SSH. Nmap also tell me that protocol is TCP and the state is listed as open, which means the service is actively accepting traffic. I also see that port 80 is open, which is the standard port from for HTTP. That means I should be able to pull up a web page from the target. When I type in the IP address in Firefox 192.168.56.101, that's the IP address. I get a simple test page for the Geoptrix server. It's nothing fancy, but it's confirmed that the web service on port 80 is running. When I view the page source, the green text shows developer comments. They are not harmful, but they are sometimes it can reveal useful details about how the page was built. In this case, it's just basic styling note. Even so, checking the source is always worth it during the immersion, because developers sometimes leave behind hints, version information, or other details that help us understanding the system better. In map operating system scan, one of the command I used is nmap hyphen o and my IP address, which is an operating system detection scan. When I run the operating system detection scan, Nmap tells me that the target is running a Linux 2.4x kernel. It does not give an exact version, but it gives a best estimate somewhere between 2.4.9 and 2.4.18. That range is helpful because older kernels often have a well documented weakness. So knowing the version helps to guide the rest of the assessment. Nmap also shows that there's only one hop between my machine and the target. That means I'm not passing through any router, firewalls, or external network devices, and that makes perfect sense because this is a virtual lab environment. Everything is running locally, so overall this scan gives me a solid snapshot of the operating system and network path, which is exactly what I need at this stage of immersion. Nmap service scan. Another command I used nmap-asv and target IP, which is another version detection scan. So I can get a clear picture of what services and version are running on the target. This type of scan digs deeper and usually gives us more specific information about each open port. From the result, I can see that port 22 is open, and this time Nmap actually provides the version details. It shows open SSH 2.9 P2 using protocol 1.99. That is important because older version of OpenSSH and older protocol level often have known weakness. This was exactly the kind of details we want to capture during the numeration. Detail intuition scan. Another command I used was nmap -p um, -a and target IP, which performs a more aggressive scan. It gives more information. This one digs deeper into the open ports and services to gather as much as information possible. Using this on the Q-Optics machine worked well. I was able to um, enumerate the system and gather more details about the device and resources running on it. While no username are revealed, it the scan did show each open port, the protocol it uses, and the version of the program running on that port. This helps identify what might be risky or outdated. Uh, for example, the scan shows that the system is running HTTP on Apache, and I also see RPC bind on port 111, which is common on older Linux system. All of this gives a clear picture of what services are active and what versions it's running. This matters because every service version number and protocol identify becomes a clue. It helps figure out what might be outdated, misconfigured, or potentially vulnerable. That's really the core of enumeration. Collection as much as information possible. It helps uh, to testing on later, deeper testing on later. For this assignment, I used three different Nmap scan to get deeper understanding of how the Q-Optics system behave. First one, I use vulnerability script scan, which use Nmap inbuilt script to check for known weakness without actually exploiting anything. This scan is great because it quickly highlights the high risk services and outdated software version, which helps me figure out what to investigate first. Next, I ran UDP scan. UDP services are harder to detect since there is no handshakes. So this scan helps uncover things that a normal TCP scan might miss, like DNS or NTP. It also reveals misconfiguration and gives a more complete picture of what the system is running. Finally, I use debug mode scan. This one is not about finding vulnerability. It is about understanding how Nmap itself is behaving. It shows detailed internal processing, pocket behavior, and timing. It's really useful when something looks off, or when um, want to confirm that port are responding consistently. So these three can give me a solid foundation of the identifying vulnerabilities, forming my flow hypothesis. So in this slide, we can see three additional Nmap comments screenshot. When we talk about the flawed hypothesis methodology, we are really talking about a structured way to think like an attacker. Instead of randomly testing things, we look how the system is behave, what version of services is running, how it's configured, and what kind of failure are common for those technologies. From there, we gathered educated guesses about where weaknesses are most likely to exist. Mm, this helps us focus our testing on the area that actually matter instead of wasting time on trial or error. Based on my findings from Qioptrix machine, I identified two major vulnerabilities that stood out right away. On port 443, the system is using weak SSL or TLS settings, mm, um, which makes it vulnerable to the logjam attack, CVE 2015 4000. And on port 139, the outdated Shamba service exposes the system to a remote code execution flaw, CVE 2009 3103. Together, these issues support the hypothesis that the system is running outdated, unpatched, and misconfigured services. Other words, it's highly vulnerable to exploitation, and their weakness gives attackers multiple paths to compromise the machine. For this part of this project, I created vulnerability map for the Qioptrix system running at IP address 192.168.56.101. The goal was to lay out all the open services, identify the risk associated with each one, and figure out which areas needed most attention. So here is the map. Shows SSH on port 22, RPC on port 111, and NetBIOS on port 137 to 138 all falls on medium risk category. That mainly because they are using outdated protocol and exposing services that really shouldn't be open. um, uh, and HTTP on port 80 is also a medium risk, especially since trace medium is enabled and directory access is too open. Uh, the high risk issue shows up on HTTPS port 443 and SMB v2 on port 139. HTTPS is vulnerable to things like logjam, CCS injection, and weak Diffie-Hellman keys, which means Encrypted traffic could potentially be intercepted or decrypted. Uh, SMBV2 on port 193 is even more serious. It's vulnerable to remote code execution, including the well-known CVE 2009 uh, 3103, which could let the attacker gain full control of the system. Mapping all of this out makes it really clear which service need immediate uh, remediation and which one pose the biggest threat to the system. Next, I looked at the flaws in more detail. SMV BV2 on port 139 has a harm has a remote code execution flaw caused by poor uh, poor bounds checking. That's a fancy way of saying that the service does not properly validate input, which opens the door for attackers to run their own code. HTTPS on port 443 is vulnerable because it's using outdated SSL TLS protocol and weak uh, cryptographic keys that makes it possible for attacker to intercept or decrypt sensitive traffic. Some of the lower risk issues include SSH-V1 on port 22, HTTP trace on port 80, and exposed RCP NetBIOS services, even though they are not as severe, they still contribute to the system's overall attack surface. All of these flaws come down to the same root causes: unpatched software, legacy protocol, and default configurations, and that were never hardened. Together, they leave the system highly susceptible to attacks. Thank you, everyone.